Hi, ladies and gentlemen. We are on notes 3.4, which is on slope as a rate of change. So let's take a look at what question number 1 says. It says the graph shows the volume of gasoline remaining in a car's tank. So question A asks you to calculate the slope of the graph. We're going to actually do this two different ways. So the first way I'm going to do it is by doing rise over run. Okay, but by looking at my graph, I see that my line is going down. Since my line is going down, I got to make sure that I know that my answer is going to be a negative answer. That's really important that you remember that. Okay, so let's go ahead and figure out how much did this rise by? How much did it go down by? How much did it go over by? Now it started at 65 here and it ended at 5. So I know it went down. If this is 65 and it ended at 5, I know it went down by 60, so it's a negative 60. That's my rise. Okay? And then my run, I want to see how much it went over by. So how much did it go over by? Well, it started at 0 and it went to 500, so it went over by 500. Okay? So I'm going to divide negative 60 by 500. And I end up getting negative 0.12. Okay, so I'm going to say that my answer here is negative 0.12, which is what we wanted to get. We should get a negative value. Okay, let's do it another way. Let's use y2 minus y1 over x2 minus x1. And let's go ahead and figure out what my values are right here. So I'm going to call this one x1 because it's my first x. This is y1, this is x2, and this is y2. Okay, so let's go ahead and do our plug in our information. So I end up getting 5 minus 65, because y2 is 5 and y1 is 65, over x2 minus x1 is 500 minus 0. So what does this end up giving me? I end up getting negative 60 over 500, which is exactly the same problem that I get here. I get negative 0.12. Okay, but it says interpret the slope as a rate of change. So we have to understand right here that I really got negative 60 liters because this went down right here. My rise was negative 60 liters, and then my run was 500 kilometers. So this is negative 60 liters over 500 kilometers. When I divide it, I get negative 0.12 liters per kilometer. So how can I interpret this? What this means is, right here, I can say that the liters decrease, the liters of gas decrease by 0.12 liters every kilometer. Okay, so that's my answer to part B right here. Okay, now part C says write an equation to represent the situation. Well, remember the general equation is y equals mx plus b, where m, we figured out, is our slope. We know our slope is negative 0.12, so I can say y equals negative 0.12x plus b. Remember our b is our initial value. Well, our initial value, where did it start off at? When x is 0, it started off at 65, so it's plus 65. Okay, then it says to interpret the equation. So what this means is the amount of gas starts at my initial value. My initial value is 65, so it starts at 65 liters, and it decreases by 0.12 liters for every kilometer driven. Okay, that's what this is saying here. So y equals, you go down by 0.12 liters for every kilometer, but you start at 65. Okay? And then part D says use the equation to determine how many liters are left in the tank when the car travels 300 kilometers. Well, if my equation is y equals negative 0.12x plus 65, and I know that it started off with, or I have 300 kilometers driven, and we know that x stands for the number of kilometers, then I can say y equals negative 0.12 times 300 plus 65. Okay, so then I just go ahead and do my multiplication. Negative 0.12 times 300 gives me negative 36, so I get negative 36 plus 65, so y equals, when I add 65 to it, I end up getting 29. Okay, so therefore there were 29 liters left. Okay, is this answer supported by the graph? Let's go ahead and see. So at 300 kilometers, if I go to 300 kilometers, am I at 29 liters left? Looks pretty accurate to me, so that looks like it'll be the right answer. Okay, and that's how we look at slope as a rate of change. So basically the biggest piece of information here is to find the slope as a rate of change. It just needs to have units. So here our slope was negative 0.12, but our rate of change is negative 0.12 liters per kilometer. So this is our rate of change. This is our slope. It's the same idea, except just the slope doesn't need units and the rate of change does. Okay? Number 2, it says Aaliyah and Emily are riding the bus. There is a fee to use the bus. So that means that there is an initial cost. If there is an initial fee or an initial cost, this is not direct variation, it's partial variation. And an additional rate per mile. We know Aaliyah goes 5 miles and pays $7, and we know that Emily goes 9 miles and pays $10.20. How much is the rate per mile? So this is the rate of change, or the slope, right? So because it's partial, I cannot just take the 7 and divide it by 5. I can't just take the 10.20 and divide it by 9, because there's an initial fee that's included in the $7 and an initial fee that's included in the $10.20. So how do I figure this out? Well, I use slope. So first thing I'm going to do is I'm going to identify what are my 2 things that are unknown. What are my 2 unknowns, or 2 things that are changing, 2 variables. So we know that Aaliyah goes 5 miles while Emily goes 9 miles. So distance is one of my variables. So we're going to let distance equal one of our variables. And we also know that Aaliyah pays $7 and Emily pays $10.20. So we're going to say cost is our second variable. But the question is, which one is the independent variable? Which one depends on the other? Well, the cost depends on how far you go. So the cost is the dependent variable, so cost is y. If the cost is dependent, then the distance is independent, so the distance is x. So based on that, I can write out Aaliyah's information as a coordinate. First I put the x, then I put the y. So first I put the distance, which is 5, then I put the cost, which is $7. So this is Aaliyah's information. Okay, let's do the same thing for Emily. For Emily, I first put the distance, I put the x first, the distance, which is 9. Then I follow it by the cost, which is y, which is $10.20. Well, now that I've done that, I can just use my slope formula. So m equals y2 minus y1 over x2 minus x1. So I know that this is my second coordinate, so this is my second coordinate and it's my y value. So my second y value is $10.20. My first y value is 7, so $10.20 minus 7. This 9 is my second x value, so I'll say 9 minus, this 5 is my first x value, so 9 minus 5. Okay, so let's go ahead and do our subtraction. So $10.20 minus 7 is $3.20. 9 minus 5 is 4. Now it's really important you know what the units are here. We have to label our units if we're talking about a rate of change, okay? So if this is $10.20 and this is $7, this is $3.20. If this is 9 miles and 5 miles, this is 4 miles. So what this means when I divide this, if I divide 320 by 4, I should get 80 cents. So this is telling me that it's 80 cents per mile. So therefore, sorry about that, right here we're going to say therefore the rate of change, or the rate per mile, is 80 cents per mile. Okay? Remember, slope is our rate of change, but our rate of change just has a unit on it. Okay, so let's look at question number 3. We've got one more to go, and then we'll fill in the blanks, and then we are going to go, or we'll be done from there. So Katie and Sarah join a gym. The gym has a joining fee, therefore we have partial variation because we have an initial fee, and a monthly rate. Katie goes for 8 months and pays $262. Sarah goes for 11 months and she pays $349. How much is the monthly rate? So here I want to define my two things that are changing. So we've got 8 months for Katie, but 11 months for Sarah. Therefore, the number of months, or the amount of time in months, is what's changing. Okay, so that's my first variable. I also have $262 and $349. So we're going to say let the cost equal, and that's my second variable. Now we know the cost depends on how long you go to the gym for. So our cost is dependent, so cost is y. And we know the amount of time that you go to the gym for is going to be independent, so that's x. So let's go ahead and write out Katie's information as a coordinate. We always do x, which is time, followed by y, which is cost in this example. So Katie's time is 8 months, and her cost is $262. So this one is Katie's information as a coordinate. Okay, then we have Sarah, and we know Sarah went for, her time was 11 months, and she paid $349. So looking at this right here, I can say 8 is x1 because it's my first x, 262 is y1, 11 is x2 because it's my second x, 349 is my y2 because it's my second y. So I can go ahead and fill in my information. y2 minus y1 over x2 minus x1. Well, when I plug that in, y2 is 349 minus y1 is 262, we figured out, over x2 is 11 minus x1 is 8. Okay, so let's go ahead and do our subtraction. So here we have 349 minus 262, and that will give me 87. But 87 what? Well, this is $349, $262, so it's $87. Okay, and then in the denominator it's 11 minus 8, but it's 11 months minus 8 months, which is 3 months. So when I go ahead and divide it, I end up getting 29. What does this mean? It's $29 per month. Okay, so the monthly rate, or the rate, we can just say therefore the rate is $29 per month. Okay? All right, so lastly, we need to write down that a rate of change requires units. So we can't just say a rate of change is 29. We have to say $29 per month, okay? And it compares how many different things? Well, we've got dollars per month. That's 2 things. We've got dollars per mile. That's 2 things, right? Over here, we had liters per kilometer. It's 2 things. So it always compares 2 quantities. Okay? And that's all we're going to do for this lesson. If you have any questions, write down notes and ask me in class. We got to make sure you totally understand all of this stuff. I hope you have a great day. See ya.